Hello, my dear children. In the previous class, we have discussed about subset and subsets of set of real numbers and intervals as subsets of real numbers. Okay, my dear children. Now we are going to discuss about power set. What is the definition of a power set? See here the definition. The collection of all subsets of a set A is called the power set of A. You know the subsets of A, how to write the subsets of A. Then if we write all these collection of subsets as a one set, then the set is called power set of A, and it is denoted by P of A. P of A denotes power set of A. So in the power set, every element is a set. Remember this point, my dear children. Okay, let us take an example to understand the definition of power set of A. Let us take A is equal to set 1 comma 2. Okay, my dear children, two elements are there. 1 and 2 are the elements of set A. Now let us write subsets of A. First and foremost subset is empty set. For every set, empty set is a subset of every set. So first we write empty set. After that we write singleton sets. Do you remember what is meant by singleton set? Only single element. So set 1, set 2, singleton sets were written. After that we have to write two element sets. So two elements, take two elements. So set 1 comma 2. That's all. These are all the subsets of set A. Now P of A is equal to set of all 5 singleton set 1, singleton set 2, set 1 comma 2. These are the elements in power set of A. Understood this, my dear children? Right. Also note that n of P of A is equal to 4. Means how many elements are there in the power set? 1, 2, 3, 4. 4 elements are there in the power set. So 4. This can be written as 2 square. So 2 power, how many elements are there? 2. So 2 power 2. In general, if A is a set with n of A is equal to m, then n of P of A is equal to 2 power m. This is the formula to find the number of elements in the power set. 2 power m. Here m denotes n of A, number of elements in the set A. Understood this point, my dear children? Right. Now come to the next definition, that is universal set. A set that contains all sets in a given context is called the universal set. Okay, my dear children. Universal set is usually denoted by capital letter U. Universal set is generally denoted by the capital letter U, and all its subsets by the letters A, comma B, comma C, etc. So subsets of the universal sets are generally denoted by the letters A, B, C, and so on. Suppose to understand this concept universal set, let us take an example. For the set of all integers, if you study set of all integers, in that case the universal set can be the set of all rational numbers, because set of all integers is a subset of rational numbers. So here the set of rational numbers can be taken as universal set in this context. Understood, my children? Right. Now come to the sums in exercise 1.3. All these sums are based on the definitions, subsets, and subsets of set of real numbers, intervals as subsets of real numbers, power set, and universal set. Based on these concepts, the questions in exercise 1.3 were given. So you must learn these concepts well before starting the sums in exercise 1.3. Okay, my dear children. Right. Now come to the first question. Make correct statements by filling in the symbols subset or not subset in the blank spaces. Here in this question, some statements are given. This question is based on the concept subset. Okay, my dear children. So, subset or not subset. We have to make these given statements correct by filling in the blank spaces by suitable symbol subset or not subset. Okay, my children. Right. See first one. Set 2 comma 3 comma 4 dash set 1 comma 2 comma 3 comma 4 comma 5. Is this set a subset of this set or not? Yes, because 2 is an element, here also 2 is an element. 3 is an element, here also 3 is an element. 4 is an element, here also 4 is an element. So every element in this set is also an element in the second set. So the first set is said to be subset of the second set. Okay, my children. Right. Now come to the second question. Set A comma B comma C dash set B comma C comma D. Is it a subset of this second set? No, because here A is an element in this set, but it is not an element in the second set. So this first set is not a subset of the second set. So we have written not subset symbol here. Understood this question, my dear children? Right. Now come to the next question. Set of all x such that x is the student of class 11 of your school. Okay, my dear children. Dash set of all x such that x is a student of your school. Is it a subset or not? Yes, because every student in class 11 is also a student in your school. Isn't correct or not? Yes. So this first set is a subset of second set. Okay, my dear children. Is it clear? Right. Now come to the next question. Set of all x such that x is a circle in the plane dash set of all x such that x is a circle in the same plane with radius 1 unit. Is the first set a subset of the second set? No, because here different circles with different radius, but here only 1 unit circles are given. So this is not subset of this second set. Is it clear, my dear children? Right. Now come to the next question, that is question number 5. Set of all x such that x is a triangle in a plane. This is the first set. Dash set of all x such that x is a rectangle in the plane. This is the second set. Is the first set a subset of the second set? No, it is not a subset of the second set. First set is not a subset of the second set, because here triangle may be any kind of triangle. It may be isosceles triangle, it may be a scalene triangle, it may be right angle triangle. But in rectangles we get only right angle triangles. We don't get other kinds of triangles. That is why every triangle in a plane is not a subset of this set. Is it clear, my dear children? Right. Now come to the next question. set of all x such that x is an equilateral triangle in a plane dash set of all x such that x is a triangle in the same plane. Is the first set a subset of the second set or not? Yes, clearly. Because every equilateral triangle is also a triangle. This is one kind of triangles. So every equilateral triangle is also a triangle in the same plane. That is why the first set is a subset of the second set. Is it clear, my dear children? Right. Now come to the next question. Question number 7. Set of all x such that x is an even natural number. This is the first set. Dash set of all x such that x is an integer. Is the first set a subset of the second set or not? Yes, because every even natural number is also an integer. Isn't it, my dear children, or not? Yes. So the first set is a subset of the second set. Is it clear, my dear children? Right. Now come to the question number 3. Here I am not explaining the question number 2 because the question number 2 is also based on the concept of subset. Okay. Will you do question number 2 as homework, my dear children? Yes. Do question number 2 as homework. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children? Right. Now come to the question number 3. See here question number 3. Let A is equal to set 1, comma 2, comma set 3, comma 4, comma 5. What are the elements of set A? 1 is an element, 2 is an element, set 3, comma 4 is an element, 5 is an element. How many elements are there? Only 4 elements. First element is 1, second element is 2, and third element is set 3, comma 4. Remember this point, my dear children. And fourth element is 5. Okay, my dear children. Now, which of the following statements are incorrect and why? We have to write the reason also. If the statement is incorrect, if the statement is a false statement, we have to write the reason also. Understood, my dear children? Right. Come to the first statement. Set 3, comma 4 is subset A. Is 3 set 3, comma 4 is subset A. It is a false statement, incorrect statement. Because previously I told you set 3, comma 4 is an element of A, not a subset of A. Set 3, comma 4 is not subset of A. It is an element of set A. Remember this point, my dear children. Second, is it clear, my dear children? Right. Now come to the question number 2. Set 3, comma 4 belongs to A. This symbol stands for is an element. This symbol stands for belongs to. Is an element. Is this an element of set A or not? Yes, it is a correct statement. Because set 3, comma 4 is an element of set A. Is it clear, my dear children? Right. Now come to the next statement. Set 3, comma 4 is subset A. Is a set a subset of set A or not? Yes, because every element here in this set only one element is there, that is set 3, comma 4 is an element. This element is also an element in the set A. So this first set is a subset of the second set. Okay, my dear children, is it clear? Right. Now come to the next statement. 1 is an element of A. Is it a true statement or false statement? Yes, it is a true statement. Correct statement. Is it clear, my dear children? Right. Next question, next statement. 1 is a subset A. Is 1 a subset of A? No. 1 is an element of A, not a subset of A. So this statement is a false statement, incorrect statement. Is it clear, my dear children? Right. Because 1 is an element of set A. Here 1 is an element of set A, but 1 is not a subset of A. That is why the statement is a false statement, incorrect statement. Is it clear, my dear children? Right. Now come to the next statement. Set 1, comma 2, comma 5 is a subset A. Is this statement a true statement or false statement? Yes, it is a correct statement because every element in the set. What are the elements in the set? 1, 2, 5. All these elements are also the elements of set A. So this set is said to be a subset of A. Is it clear, my dear children? Right. Now come to the next statement. Seventh one. Set 1, comma 2, comma 5 belongs to means is an element of A. Is this an element of A? No, it is a false statement because set 1 comma 2 comma 5 is a subset of A, but set 1 to 5 is not an element of A. It is this entire part is not an element of A. It is only a subset of A. That is why this statement is a false statement. Is it clear, my dear children? Right. Now come to the next statement. Set 1, comma 2, comma 3 is subset A. Is the first set a subset A? It is a false statement because here 3, 1 is an element of set A, 2 is an element of set A, but 3 is not an element of set A. 3 is not separately an element of set A. That is why this first set is not subset of set A. Is it clear, my dear children? Right. Now come to the next statement. 5 is an element. We can read it as is an element or sometimes belongs to. Both denote the same. 5 is an element of A. Is this an element of A? No, it is not. 5 is not an element of A. It is only a subset of A because empty set is a subset of every set. Previously, we have discussed that point. So, it is a false statement, incorrect statement because 5 is not an element of A. 5 is a subset of A. 5 is not an element of set A. Is it clear, my dear children? Right. Now come to the next statement. 5 is a subset A. Is it true statement or false statement? Yes, it is a true statement, correct statement because 5 is a subset of every set, empty set. 5 means here null set. You have already studied, you have already learned, we have already discussed this point. Empty set or null set or void set is a subset of every set. That is why the statement is a true statement. Is it clear, my dear children? Right. Now come to the next statement. Set 5 is subset A. Is a set 5 a subset A? No, it is a false statement because in this set, what are the elements? 5. 5 is an element in this set. Is this element an element of set A? No, it is not an element of set A because 5 is not an element of set A. That is why this statement is a false statement, incorrect statement. Is it clear, my dear children? Right.